In our lesson today, we're going to be analyzing percents of numbers, and we're going to be using the percent equation to help us answer our questions. In our first example, it says that Diego starts a 12-hour road trip with his phone's battery charge at 75%. Given his normal usage, will his phone last for the whole trip? Okay, so we're going to start by writing the percent equation, which remember says that the part is equal to a percent times the whole value. Okay, we always find a percent of the whole value to represent the part. So looking at our picture, okay, here's the phone and the battery when it's fully charged, 100% battery charge, there's 15 hours. Okay, so a full battery will last for 15 hours. Okay, but down here, his battery isn't fully charged yet. Okay, in the picture, it ends right here. And it says that that's a 75% charge, and we have to figure out how many hours that is going to be. Okay, so since there's 75% remaining, that's what we're going to plug in for our percentage here. But when we use this equation, we change the percent into a decimal. All right, so remember, 75%, move the decimal back 2 times to the left, and that means we're going to write down 75 hundredths for our rate. Okay, the other thing that we know is that the full battery lasts for 15 hours. Okay, we're going to try to find the part P that represents how long his phone will last with only 75% charge. So the full battery is 15 hours. How many hours is it when it's only 75% full? To calculate the part, all we have to do is multiply 75 hundredths times 15. And when you punch that in, you get an answer of 11 and 25 hundredths. Okay, well, remember, this is the number of hours that the phone will last. And if you think about a quarter hour, this is really 11 hours and 15 minutes. But they told us that the road trip was a 12-hour road trip. So we can say that Diego's phone will not last the whole trip. Okay. Diego's phone is only going to last 11 and a quarter hours, or 11 hours and 15 minutes. The trip's 12 hours, so he's going to be without a phone for 45 minutes unless he has a phone charger. In our triad example, we're told that Katie's phone had a fully charged battery. With normal usage, her phone will last for 18 hours. How much time is left on Katie's phone battery at a 12% charge remaining? So we'll start with our percent equation, which again says part equals the rate or the percent times the whole value. We always find a percentage of the whole value. And this time, Katie only has 12% remaining at some point. So we're going to change that into a decimal, move the decimal point back twice, and that's going to be 12 hundredths. We're also told that if it's fully charged with normal use, the phone will last for 18 hours. So the whole battery will last 18 hours. We're looking for the part P that will represent how long it lasts with only a 12% charge. So again, to get that part, all we have to do is multiply 12 hundredths times 18. And that gives us an answer of 2 and 16 hundredths. So this means that Katie's phone will last 2 and 16 hundredths hours with a 12% charge. In example 2, we're going to have a percentage that is greater than 100%. They tell us that a full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many teeth are there in a full set of adult teeth? Okay, so once again, we'll start with the percent equation. Part equals percent times whole. And they tell us that the adult teeth is 160% as many as the set of baby teeth. So for our rate, we have 160%, move the decimal point back 2 times to the left, and that's going to give us a decimal of 1 and 6/10. Now remember that we always find a percentage of the whole value. We need to figure out what's 160% of the baby teeth. Okay, that's what we're doing here, 160% of the full set of baby teeth. Well, looking at the picture here, they tell us that there are 20 baby teeth. Okay, so the baby teeth represents the whole value, 160% of the baby teeth, percent of the whole value. So we'll plug in 20 for the whole value. And that means we're looking for P, the part. Notice that we're multiplying by a number that's bigger than 1, so our answer should get bigger, which makes sense because adults have more teeth than babies do. Okay, so when we multiply 1 6/10 by 20, that's going to give us an answer of 32. And this means that adults have 32 teeth. Okay, so when you multiply your whole value by a percentage more than 100%, the part is actually going to be bigger than the whole. Adults have 32 teeth. In example 3, we're going to be using a percent that is less than 1%. The question asks, what is the approximate distance in miles from the Earth to the moon? And we have a diagram here that's going to help us with that. Before we do that, though, let's set up our percent equation. The part is a percentage of the whole value. Okay? Well, the diagram has all the information that we need. Okay, we're looking for the distance between the Earth and the moon. Okay, here's the Earth, here's the moon. And this little distance here, it says, is 27/100% of the distance between the sun and the Earth. So there's our percentage, 0 and 27/100%. But remember, to use this equation, we write the percent in decimal form, which means we need to take this decimal point and move it 2 times to the left. And we have an empty spot that we'll fill in with a 0. That changes the decimal into 27/10,000ths. 27/10,000ths. Now remember, we always find a percentage of the whole value. This says 27/100% of the distance between the sun and the Earth. So the distance between the sun and the Earth is going to be our whole value. And we can see in the diagram here, this is the sun, this is the Earth. The distance between those is 93 million miles. So our whole value is going to be 93 million. We're looking for P, the part, which represents the distance between the Earth and the moon, which again is 27/100% of this distance between the Earth and the sun. Okay, so to get P, the part, we're going to multiply 27/10,000ths by 93 million. Make sure when you're using your calculator that you punch your numbers in carefully. And when you do that, that should give you a value of 251,100. Okay, so this means that the Earth and moon are 251,100 miles apart. Okay, so when your when your percent rather is less than 1%, okay, remember that this isn't in decimal form because we see the percent symbol. To change this into a decimal, move that decimal point twice to the left, and that is the value that you would use in your percent equation. In our triad examples, we have percentages that are less than 1%, and we have an example where the percentage is more than 100%. We're going to find each of these by using the percent equation. So let's start with letter A. Part equals a percentage of the whole value. Okay, in this case, we're finding 8/100ths% of 720. Again, this is your percentage. To change this into a decimal, move that decimal point back once, twice, and that will make it in decimal form equal to 8/10,000ths. We always find a percentage of the whole value. So the whole value in this case is 720, and we're looking for P, the part. So we have to figure out what is 8/10,000ths times 720. And when you multiply those together, the part in this example is going to be 576,000ths. In letter B, we're finding 162.5% of 200. Once again, part is a percent of the whole value. For your percentage, 162.5%, again, make it a decimal, move the decimal point back once, twice. So we would have 1 and 625 thousandths. And we find a percent of the whole. So the whole value in this case is 200. And we're looking for p the part. So we'll have to do multiplication. And again, when you multiply the whole by a number that's more than 1, our part is going to be bigger than the whole. So we have to do 1 and 625 thousandths times 200. And when we do that in this example, the part is 325. Finally, in example C, part equals a percentage of the whole value. We have another percent less than 1%. That's the percentage. Make it a decimal, move the decimal point back once, twice. All right, so 0.3% is equal to 3 thousandths in decimal form. And once again, it's a percentage of the whole value. The whole value is 60. Find p the part. When you do 3 thousandths times 60, 3 thousandths times 60, that gives you an answer for the part of 18 hundredths. In example 4, we're told that in Ty's math class, 20% of the students earned an A on a test. If there were 30 students in the class, then how many got an A? So we'll use our percent equation to help us out with that. Part equals a percent of the whole value. And they told us that 20% earned an A, 20% as a decimal, move the decimal point back 2 times. You can either write it as 20 hundredths or 2 tenths. They're the same answer. And then they said that there were 30 students in the class. That's the whole class. So we'll put in 30 for the whole. We want to know how many got an A. Well, only part got an A, 20% of them. We're going to have to do this multiplication to figure out the part that got an A. If you do 2 tenths times 30, that gives you an answer of 6. So we can say that 6 students got an A on the test. 6 students got an A on the test. In example 5, we have that in Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 25 art projects turned in by Ty's class. How many of the art projects earned a perfect score? So we'll use our percent equation, part equals percent times whole. And this is very similar to the last example that we did. They gave us the percentage, 12% received a perfect score. Change that to a decimal, move the decimal point back twice. For our rate, we're going to have 12 hundredths. There were 25 art projects turned in, so that's all of the art projects. That's the whole value. And we're looking for the part P, how many of them earned a perfect score. Not all of them did, only 12% did, so we're looking for the part. So in order to do this, we're going to multiply 12 hundredths times 25, which gives us an answer of 3. So we can say that 3 art projects received a perfect score. 3 art projects received a perfect score. In example 6, it says that in Ty's English class, 70% of the students completed an essay by the due date. There are 30 students in Ty's class. How many completed the essay by the due date? So let's set up our percent equation. Part equals percent times whole. Okay, 70% of the students did their essay by the due date. Change 70% into a decimal. Move the decimal point back twice. For the rate, we can have 7 tenths or 70 hundredths. 30 students are in Ty's English class. So the whole class is 30 students. We have to figure out P the part. How many did it by the due date? How many did their essay by the due date? So if we multiply 7 tenths or 70 hundredths times 30, that's going to give us an answer of 21, which means that 21 students completed the essay. 21 students completed the essay by the due date. Okay, so using the percent equation can help us answer these questions. Part, percent, whole, we're always going to be given two of these values that we can plug in, and then we just use our algebra to figure out the missing one.